Next, let's implement part 2, JWT generation, by following this sequence diagram. Let me toggle over to IntelliJ. First, let's create 3 classes under package security. Auth controller, and let's annotate it as REST controller. Then create auth service at service, and JWT provider. Now this time, we can simply just annotate it as at component. You can also annotate it as a service, doesn't matter. Okay, based on the sequence diagram, we know that auth controller depends on auth service depends on JWT provider. So let's wire them up. And for provider, it's not depending on anything, at least for now. Let's define a handler method to handle the login API endpoint. So public result get login info. So this method is supposed to return the basic user login information and a JSON web token. It takes authentication as parameter. So make sure you're importing the correct one. So this authentication should be from org.springframework.security.core. Based on the API documentation, this should be a host request. And here, let me use the class level request mapping as well. API.endpoint.base URL users. So here we only need to write login. Also want to show that it is a good idea to use a logger in this controller class. Pass in the class. So here we can log, debug some information in this authentication. For example, here I can say authenticated user authentication.getName. So this will print the username, like John, Eric, Tom. What is this authentication? And who is passing this authentication to get login information? Let me remind you that when the control flow arrives in this handler method, get login info, the basic authentication is done successfully. That means the user is authenticated, is done, is a valid user. The authentication provider will prepare this authentication, and then Spring will inject it into this formal parameter of this method. So here in this handler method, we can access the information of a logged in user. So simply put, you can think of this authentication object as a representation of an authenticated user. And in part 2, we're going to retrieve information from this authentication to create user info and also the JSON web token. Okay, so here we can simply just return new result, true, status code dot success. And here we're going to put user info and JSON web token. And for the data, right now we haven't created a token. Let's just return authentication.getName to test if this works. Okay, so let's turn it off and run again. Okay, it's running. Let's go to Postman. So under user, let's create a new request. And let's call this login. This is a post request. Let me reuse this. Login. And here in the authorization, I have to provide basic auth, John and 1, 2, 3, 4, 5, 6. That's good. Okay. Then send. As you can see, the handler method get login info successfully retrieves the name from the authentication, like here. Okay. Next, let's go ahead and implement auth service and JWT provider. Well, it turns out that here we're supposed to call a method from auth service. This dot auth service dot create login info. And then we're going to pass this authentication to it. At this moment, this method does not exist. So let's create a method in auth service. And here we're going to change this to map string object. Recall the successful response of the login API endpoint. Besides the token, we also prepare something called user info. It has ID, username, enabled, and roles. So my plan here is to create 2 entries in this Java map. One entry stores user info, and the second entry stores token. So let's do this. Create user info. Then create a JWT. Then how do we retrieve the user information from an authentication? Well, it turns out that after authentication, the authentication provider will save the myUserPrincipal object in this authentication object. So authentication.getPrincipal, and here we have to do a cast to myUserPrincipal, and then assign this to a variable. And from here, we can retrieve the Hogwarts user. Principal.get Hogwarts user. Okay, but be cautious. We do not send this Hogwarts user back to the client side because this Hogwarts user has the password. Then what should we do? Let's convert it to a user DTO. So that means we need to inject the converter into this class. And this time is user to user DTO converter. and add constructor parameter. Okay. This dot user to user DTO converter dot convert. We're going to pass this Hogwarts user we just retrieved from my user principal. And let's call this user DTO. Okay, now in this portion, let's try to call a method that does not exist yet. And here is called create token based on the authentication. It's not there yet, don't worry. But let's assume that the token has been created. And here is that token. So we have the user DTO ready, we have the token ready. Then let's put them into a map. Map string object. And let's call this login result map. And here we're using a hash map. Login result map dot put. Then the first entry is, now make sure you're looking at the API documentation. It's called user info. I'm going to pass the user DTO to it. And the second entry is just called token, right? Then token. And finally, we can return this login result map to the controller. So here, the controller will serialize this map into JSON string, just like this you see on the screen. Okay, so it's not easy, right? Let's go back here. Now, line 32 is complaining, of course, because JWT provider is empty. Let's do some quick testing here. So first of all, let me comment out this and just make this token empty. Okay, so right now token is empty. I want to test if the correct format is returned. All right, so let's turn off this and launch again. Then let me toggle over to Postman. Everything's good. So John 1, 2, 3, 4, 5, 6, send. Okay. So if you compare this with the success response in the API documentation, they look very similar, right? So we have two parts in the data, user info with ID, username, enabled rows, and also here the token is empty. This is expected because right now we haven't created a JSON web token yet. Now let's go back to IntelliJ and work on JWT provider. So let me uncomment this and delete this line. Line 32 is complaining because right now JWT provider is empty. So we're going to create a method called create token. Good. Then how do we create a JSON web token? Now remember the slides. It is not an easy process. Apparently, we don't want to do it by ourselves. We want to use a library. Recall a dependency we brought in. It is called Spring Boot Starter OAuth 2 resource server. It has a dependency called right here, security OAuth 2 HOC, which has a dependency called Nimbus HOC JWT. So 3 levels. Now, this guy here actually provides JWT encoder and decoder. So we can use this to help us create a JSON web token. Now remember, we also need to digitally sign a JWT. As I mentioned before, we're using a public-private key pair to sign this token. In other words, to create the signature element of this token. But first, we need to use Java to create a public and private key pair so that we can use it to digitally sign this JWT. So let me show you how to do that. Let's go to security configuration. So first, let's define two private fields. One is called private final RSA public key. And let's just call this public key. And the second one is, no surprise, because we need a pair, RSA private key. Okay. Next, we need to generate a pair of keys, and we can do that in the constructor. So come down here. Select none. So at this moment, it's an empty constructor. Generate a public private key pair in Java. Java offers a utility class called key pair generator. It is from Java.security package. And here we're using factory pattern, get instance. We're going to pass in the name of the algorithm, which is RSA. So we're using RSA to create this key pair. And it's complaining. So we're going to add this exception to the signature. So this is just in case the algorithm you passed there is not supported. Okay? Then let's assign it to a variable. Let's call this key pair generator. So we have this generator. So next, before we use this key pair generator to generate a pair of keys, so let's configure it dot initialize this one. And here we're going to specify the key size. Here I'm going to use 2048. Okay, so here's a comment. Then the generated key will have a size of 2048 bits. Okay, and of course you can increase or decrease it, but here I'm using 2048. Okay, after initializing, we can use this key pair generator to generate key pair. Okay, so this is a very straightforward name. And we're going to assign it to a key pair. Okay. But we need the keys in the key pair, right? This dot public key will be initialized to key pair dot get public. And this dot private key will be equal to key pair dot get private. That's it. But it's not happy because this one returns a more general class called public key, but this is a more specific class. So let's downcast it to RSA public key. And here will be RSA private key. Now you're happy. Okay, when this class is instantiated, these two keys will be created on the fly. Now remember, every time you restart your Spring Boot project, then you have a new pair of public private keys. Good. Now, next, as I said before, we need to prepare the encoder and decoder. We don't need decoder for now, but let's just get them ready together. So let's start with encoder. Public JWT encoder. So JWT encoder. And this method will return an instance of JWT encoder. But before that, we have to do some configuration. So JWK, make sure it's from Nimbus. JWK new RSA key dot, we're going to use builder pattern again. As you can see in Spring, there are a lot of builder patterns. Then we're going to pass in the public key and also the private key. Private key dot build. So this returns an instance of JWK. And by the way, JWK stands for JSON Web Key. Next, we need to create a JWK source, security context, JWK set, new immutable JWK set, and here we're going to pass new JWK set and pass in JWK we just get from the first step. Okay, it's not easy. Now finally, we can return an instance of Nimbus JWT encoder. And of course, we have to pass the JWK set to it. Okay, so that's for encoder. But don't forget to expose it as a bin. So Spring Boot will inject this into the JWT provider. Okay, let's do it now. Private JWT encoder. And as usual, we're going to use constructor for dependency injection. So this guy here, this new Nimbus JWT encoder, actually will be injected here and used in this create token method. Now before that, let's make sure we also create a JWT decoder. Now we need that to verify tokens. So public JWT decoder. And this time the code is pretty simple. So return Nimbus decoder dot with public key. Okay, this dot public key dot build. So this is still a builder pattern. So what happened is we use the private key to encode a JWT, and we use a public key to verify if it is okay. This public key can be distributed to different servers, maybe a Spring Boot server, a Python server, a JavaScript server. But make sure you are keeping the private key secret in one place, for example, an authorization server, and never reveal it to anybody else. Okay? Simply put, private key for encoding, public key for decoding. Then let's go to JWT provider and see how do we encode it. Okay, right here. So first, let's get the current time, because there's one claim called IAT, means issued at, and also there's an expiration time. Instant.now. So let's assign it to a variable called now. That's the issued at time. Let's also define a variable called expires in 2. So that means 2 hours. The token is only good for 2 hours. And of course, you can change it to 12 or even 24 if you do not want your user to log in every 2 hours. Now, next, let's prepare a claim called authorities. Okay, recall that in the JWT.io decoder, there is actually a claim, a key-value pair called authorities, and is equal to role_admin space role_user. Okay, so here's how we do that. Authentication.getAuthorities. So this will return a collection of granted authorities. So let's first convert it into stream, so we can use stream APIs. Now, this is interesting because this is the inverse of what we did before. Now, if you remember, in my user principal class, we're converting a string to a collection of granted authorities. But this time, we're doing the reverse. We're going to convert a collection of granted authorities back to a string. And we're going to join in all those strings using space. So it's exactly the opposite of what we did before. So dot map. So here we have granted authority dot get authority. This returns the string, for example, role_admin or role_user, and so on and so forth. But then we need to collect those individual strings into one string, and using joining, here we're going to pass space. So just pay attention to here. This one must be space delimited. Then let's assign this result into a string called authorities. Okay, let's create all those claims. And again, we're still going to use a builder pattern, JWT claims set dot get the builder dot build. Okay, so here let's build them one by one. So here we're going to define 5 claims. Dot issuer and itself. So that means we're not using a dedicated authorization server. Everything is done with this one server. Then issued at will be now. And of course, next will be expires at. Now dot, there's a plus. Okay. Expires in, and we have to specify the unit, which is chrono unit.hours. Then dot subject. Now this time it should be authentication.getName. So in this case it's John. And also here we have a claim. This is a self-defined claim. As you can see, issuer, issued at, expires at, subject. Those are built-in claims. And you can also define your own claims. And you have to use this dot claim and give this key value pair to it. Let's just call it authorities. And here is the string authorities. Okay. Let's assign this to a variable called, this is called claims. So here are the 5 claims. And we're going to encode the 5 claims using this dot JWT encoder. And this is the one we just injected in. And not surprisingly, it has a method called encode. But instead of passing the claims directly in, we have to convert the claims into something called JWT encoder parameters. So JWT encoder parameters dot from. So we get those parameters from the claims. Dot get token value. There you go. Okay, quick summary. Before encoding, we have to prepare the claims. So we get the current time, and also we defined expires in. We also retrieved the authorities from authentication and converted them into a space delimited string. Then we created a JWT claim set. And finally, we use JWT encoder to encode those claims. So line 40 will return us a very long JSON web token. Okay, so let's test. Let's run it again. Okay, it's happy. Let's go to Postman. Now this time we're actually expecting something here in the token. So send. Great, the token is there. This is the header, dot. Then this is the second part, which is the payload. Okay, it has 5 claims. And here we're using the private key to digitally sign this token. If someone modifies this token, then this token becomes invalid. It can be detected. We're almost there. So let me close this, and close this. Okay, at this point, we have successfully completed part 2, JWT generation. Let's go back to the slides. Once a JSON web token is returned to the client, for subsequent HTTP requests, the client no longer needs to pass username and password. Instead, it will attach this token with the request. Here is what I mean. Let's say after logging in, this user wants to delete another user with ID equal to 3. So this is the process. The client sends a request with a valid JSON web token. Before the request gets to a handler method in the user controller, it will be intercepted by Spring Security. This request will be handled by an authentication provider, which retrieves the JWT and verifies if it is valid. In this context, valid means it is authenticated and it also has the authority to perform this delete operation. In the happy path, everything's okay. Then the control flow moves on to the user controller. And finally, deletion is successful. Next, let's enable JWT verification in Spring Security. Let's go back to IntelliJ. So now we're in security configuration. After line 65, remember line 65 enables HTTP basic, that's part 1. Now we're going to enable JWT verification or JWT login. Dot OAuth to resource server. And we're going to pass in a lambda. OAuth to resource server. OAuth to resource server dot JWT. So this is the default configuration. Now, Spring Security will help us verify the authenticity of a submitted JSON web token. So now we're using JWT for authentication and authorization. We need to turn off the session. So here is the syntax. Dot session management dot session creation policy dot stateless. So basically line 68 tells Spring Security that do not keep a session for any request. This can save a lot of RAM when there are a lot of logged in users. I know we wrote a lot of code, but there is really another thing we need to config. That is something called JWT Authentication Converter. So after JWT decoder, let's create a method that returns JWT Authentication Converter. Here is the name. And let's make it a bin as well. So Spring Security will use it to convert JWT into an authentication in Spring Security. So let me write the code first, and then I will explain. JWT granted authority converter. New JWT granted authority converter. Okay. Then we're going to set authorities claim name to authorities. And then JWT granted authorities converter dot set authority-prefix to empty. So basically we're removing the default authority-prefix. And next, let's create a new JWT authentication converter. New JWT authentication converter. And set its JWT granted authorities converter to this guy, the one we just created. Okay, and finally, we're going to return this JWT authentication converter. Let me explain. Recall that one of the 5 claims is called authorities. Unfortunately, that is not a built-in claim. So we have to tell Spring Security to find authorities from a claim with name authorities. That is line 94. As I mentioned before, computer is not that smart. simply writing down the English word authorities will not let Spring Security realize that that claim name stores all the authorities, so we have to explicitly tell it by configuration. That's line 94. Line 95, we're setting the authority prefix to empty because the default authority prefix in JWT is scope underscore. If we do not write line 95, Spring Security will add this prefix scope underscore in front of our role underscore admin or role underscore user. That will mess up everything. That's why we have to explicitly set it to empty. Don't add anything to my authority names. Just keep it as is. And of course, after we make the changes, we have to return a new authentication converter that knows how to interpret the token. So that is line 97 to line 99. So Spring Security will use this converter instead of the default converter to convert a JSON web token to a Spring Security authentication. So we're almost done. So let me check if there is any problem. Okay, here we forgot to expose it as a bin. So this authentication converter, JWT decoder, and also here, line 69, together, they are used for JWT authentication and authorization. Next, let's have a quick test in Postman. Let me stop this and run it again. Okay, so it looks like our program is started successfully. Next, let me toggle over to Postman. First, we need to log in. Click Send. So we're getting this token. Let me copy this. Let's use delete a user to test. Let's go to delete a user. Then here's the question. How do we attach a JSON web token with a request? Now in Postman, under authorization, click type and click bearer token and just paste the token in. Save. Now let's click send. As you can see here, we have successfully deleted the user with ID equal to 3. Now recall that only user with admin role can delete a user. And now this user with ID equal to 3, which I believe is Tom, is gone. And let's verify. Let's go to find all users. And if you click send, it won't work. You get a 401 unauthorized because we forgot to attach the JWT. So let's go here and click bearer token and send. There you go. We only have 2 users, John and Eric. Tom is gone. However, it is kind of tedious to attach the token to every single API endpoint. Is it possible that we save this token somewhere so all the API endpoints can share it? And the answer is yes. Do you remember when we click this type? The default value is called inherit auth from parent. So let's click here. The parent of everything here is this project. So let's click here. And in the authorization, instead of no auth, let's go to bearer token and paste this token and save. Now let's go to find all users again. As you can see, now we don't have any token here. It is inherited from the parent. Click send. It works as well. And here is another cool feature in Postman. Look at this base URL, localhost 8080/API/v1. Right now, it is hard-coded in every single API endpoint. So if we bump from version 1 to version 2, then we have to go through every API and update that, so which is very tedious. Is it possible we save it somewhere and have all the API endpoints share it? Of course. Let's go to the project, and there is a tab called Variables. Let's click here. We can create a new variable. Let's call it base_URL. Paste the URL here and here. Okay, save. And then let's go back to find all users. Now we can delete this guy and reference that base underscore URL. And here is the syntax. The mustache notation, curly braces, and base underscore URL. Okay, and save. If you move your cursor over, it tells you the value in this base URL. Okay, so save, click send. You see it works as well. So I highly recommend you use the two features here: authorization and also the variables. Okay, now let's go to find all users. I want to show you where Postman stores the token. So if you click headers, click this 8 hidden, and scroll up, there it is. This is how you store a JSON web token in an HTTP request. The client sends HTTP requests with an authorization header that contains the word bearer, followed by a space. Maybe you cannot see the space here, but there is a space. And then the JSON web token. In your front-end project, for example, Vue.js or React.js, you can easily use Axios to create this authorization header. And even better, I recommend you use Axios request interceptor to make sure all the requests will have this authorization header with the correct token. Just remember, bearer space JWT in authorization request header. In the end, let's test using curl. So let me copy this entire thing here, copy, and then toggle over to my terminal. So curl HTTP localhost 8080 API v1, for example, users. And we're going to add a header, -h, authorization, and paste. Bearer space JSON web token. And also I'm going to make it -v to show me some details. Press enter. There you go. As you can see, we have true 200, find all success, and we only have 2 users because Tom is gone. In the next video, let's talk about Spring security exceptions and how to handle them elegantly in a controller advice. See you in the next video.